Welcome to the continued video program series to help us get ready for our midterm exam. This video will focus on problems from Unit 4 on the stack of problems for review for midterm. So Unit 4 talks about markups and markdowns. The most significant thing here is to realize whether you're basing your markup on cost or whether you're basing your markup on selling price. So read the problems carefully with no further lapse. Let's go to problem 16. Tim's buying Sony's from his distributor. He wants a 40%, 45% markup on selling price. And the problem says he's going to sell that for $1,000. And the question for you is, can you help his cost? And I should say, can you find his cost and the amount of markup? So straight in 1,000 for selling price. 450 is his markup. He's marking up 45% on selling price. So in this case, since we know both of those numbers, we can calculate the dollar value of that markup by simply multiplying 1,000 times 0.45. So this problem involves a $450 markup. So if you're asked to find the cost, you're simply going to plug in those values, solve that little equation for C by subtracting 450 from both sides. And you realize in problem 16, his cost for the TV was $550. He marks it up $450, sells it to someone walking into the store for $1,000, and problem 16 is done and in the books. Problem 17. If you read the problem critically this time, we're seeking a 55% markup on selling price. So what we know is the cost of the particular item. All right, so it's an end table in this problem for $800 cost. Your unknown is selling price, and to a certain extent, your unknown is also markup, and you see it represented on the screen at 0.55s, 55% of the selling price. You and I are going to solve a problem that now has variables on both sides, so let's move the s terms to the left side, if you will. So we'll subtract 0.55s from both sides. That leaves us 0.45s, and that amounts to the $800. So it's a divide by 0.45 will find for us the selling price for the end table, and it comes in at $1,777.78 on a roundup. So again, working carefully in terms of, is the markup based on selling price or on cost? This time it was selling price, and we had a little bit more of an algebraic solution to get us to our answer on 17. Slide it up. Let's look at 18. 18 says, hey, you know what I'd like? I'd like a 79% markup on selling price, and the individual cost is $35 per gallon. So it's similar to what you saw on problem 17 in that your unknown in this context is showing up relative to selling price as S or 1S, if you want to think about it. Markup at 0.79S because you're looking for a 79% markup based on selling price. As before, subtract both sides at 0.79s to cluster your S terms to the left side. Grab your calculator and divide both sides by 0.21, and you find out that the selling price per gown in Gabby's gowns is $166.67. Okay. In this problem, I was fascinated by the fact that we bought 600 prom gowns and it really wasn't necessary to be used anywhere in the solution of the problem. So a little extraneous information just to mess your brain up. So don't get snagged by that. All right, problem 18 in the books, selling gowns at $166.67. Let's slide solutions and we'll get 19 in here. All right. I think that's on screen. We can take a look at what we got. All right, 19 says the CAM's cabinet sells to contractors 42% markup on cost. So in this context, we're being asked to find cost. So that C is an unknown. Markup also a bit of an unknown expression in that it's 42% of the cost. So in this context, we have all our C terms on the right-hand side. So we're going to add 1 and 0.42, and that's the 1.42C calculator time. So it's 9,500 divided by 1.42. Takes us right to the value for the cost, $6,690.14. Again, be careful. Is your markup based on cost or is your markup based on selling price? On problem 19, CAM's cabinets, we're basing 42% on cost. So it's a straight shot into the algebra setup, make your algebra work for you, and one step divide and you're out. Problem 19 in the books. Let's slide to 20. We got a little flash of light there. I think we'll be okay. Looks like 20 is going to ask us for a percent or a break even. So looking at what we've got, it costs us $14.25 to make each of these toy cars, and we're selling each toy car for $29.99. So what we'll find is in a set, how much profit are we making for each toy car that we sell? So it's the difference in those numbers. So we're making $15.74 profit for each toy car. In the context of the problem, we have to defray or offset a fixed cost of $314,800 before we show a profit. So we're able to make a profit, or able to at least contemplate a profit of $15.74 for each car that we make. So what we need to find out is how many cars at that amount does it take to offset $314,800. So it's a clean divide. So we're going to find out that we will break even. In effect, we will match $314,800 in fixed costs for this particular establishment if we can sell 20,000 of the toy cars. So hopefully it's a really hot item. It's the item to have for this year's Christmas and holiday season. So the answer to the problem at a break-even spot, 20,000 cars sold will get these guys a break-even location. Should they sell one more car than 20,000, they will make a profit. Okay, if they sell less than $20,000, they do not offset their costs, and they would be operating their business at a loss. So that, my friends, wraps our look at the problems from Unit 4. Oh, I'm sorry, we got one more to go. My bad. We got problem 21. I got lost on that one. So 21 says I like this. It involves food. All right, so we're going to sell some cookies, and it's going to be a grand old time. Okay, costs $1.10, and hoping to make a 35% markup based on selling price. So again, you see your beginning set there. If you want to take it per cookie, that's what you see on the left side of this calculation set. And if you say, well, I kind of want to take it for all of the cookies, then you could certainly say, well, we're going to talk about 45 times each of those values. And you could have run that set of arithmetic, but I chose to do it per cookie and then multiply. Your author, I believe, does the full cost, and then he plays it out from there. So in the context of what you see on your screen, $1.10 was the cost per cookie. We're seeking a 35% markup on selling price. Move the S terms to the left side by subtracting 0.35S. Go ahead and grab your calculator and divide $1.10 by 0.65, and you realize that the selling price for cookie should be about $1.69. And if you're going to do that for 45 cookies, you're going to have a selling price of 45 times that, or $76.15 for all of the cookies. The problem is you're going to lose some cookies. They're not all going to be good enough to sell because of crumbles or whatever. And the problem says we're going to lose 15%. So the next part, what you see on your screen, is how much is your loss? Your loss is 15% of the 45 cookies that you make. That's 6.75 cookies. In terms of context of selling, if 6.75 are no good, you have to figure out that the 0.75 is part of the next cookie. So 7 cookies won't be able to be sold. Right? As it turns out in this problem, the way I would approach that is even if it was 6.1, that's still more than 6 cookies that would have been ruined, and you would have still said 7 cookies are not available for sale. So 45 take away 7 means we'll be selling 38 cookies, and we know over there what the selling price needs to be for us to come up with a 35% markup on selling price, and that's that reference number at 76.15 that we had just a bit ago. So to find the cost for each cookie, here's what we're going to do. We're going to take the 76.15, which is the amount of money we've got to gain as a result of our cookie sales, so we can show the desired markup. And we're going to divide by 38 because only 38 of the cookies are available to be sold. If we do that successfully, we'll find that each cookie is going to sell for $2. All right, so that finishes our work on problem 21. We had to deal with markups. We have to deal with markups relative to cost or to selling price. So read each of these problems critically and make sure you set up your formula correctly. That, my friends, wraps the problem set from Unit 4. I'll be back soon and we'll look at Unit 5. See you then.